What if the hidden reasoning inside top AI models is not actually hidden at all? A new paper says those encrypted traces may be recoverable, and in some cases they appear to contain private data. Welcome to the Automated Daily, Hacker News Edition. The podcast created by generative AI. It is August 12th, 2026. I'm Trent Teller. Today, we have a serious AI security warning, a useful way to understand why LLMs look a lot like compressors, a milestone for the Mojo programming language, a new step toward text-generated 3D worlds, and a great story about the hardest working font in Manhattan. This episode is brought to you by CrispCall. CrispCall provides agentic cloud telephony for modern businesses. Find the link in the episode notes. We start with the most consequential story today, a security paper that challenges one of the core assumptions around modern reasoning models. The researchers say they were able to recover proprietary reasoning traces from encrypted API outputs, then feed those traces into weaker sibling models from the same providers, and jailbreak them into revealing the hidden chain of thought in plain text. According to the paper, the method worked across frontier models from OpenAI, Anthropic, and Google. The more troubling claim is what showed up inside those traces. After collecting public agent trajectories, the team says it reconstructed hundreds of privacy artifacts, including API keys, passwords, access tokens, email addresses, names, postal addresses, and internal URLs. If that finding holds up, it matters on two levels. First, hidden reasoning may leak sensitive information, and second, provider protections meant to keep these traces private may be weaker than many users assume. This is exactly the kind of result that could reshape how labs handle model outputs, agent logs, and enterprise trust. Staying with AI, one of the better explainers making the rounds today argues that data compression and large language models are really solving the same basic problem, predicting what comes next. The piece walks from simple compression ideas into arithmetic coding, then connects that logic to how LLMs assign probabilities to the next token. The value here is not just technical elegance, it gives people a much cleaner mental model for AI. A compressor gets smaller files by exploiting patterns. An LLM gets better text by learning those patterns too. The goals are different, but the mathematics underneath them overlap in a very real way, especially around entropy and cross-entropy. For anyone trying to make sense of why language models work without getting buried in jargon, this is a useful bridge from classical computer science to modern AI. On the developer tools side, Mojo has reached version 1.0, which is a meaningful milestone for a language that has moved quickly from attention-grabbing prototype to something its creators now describe as stable and production-ready. The new release focuses less on flashy reinvention and more on consistency, cleanup, and developer confidence. That matters because programming languages usually become interesting only after they stop feeling experimental. Mojo has been pitched as a way to combine Python-friendly ergonomics with systems-level performance, especially for AI and high-performance computing. Hitting 1.0 does not guarantee broad adoption, but it does signal that the project wants to be judged less as a demo and more as infrastructure. For teams watching alternatives in the AI tooling stack, this is the point where the language becomes easier to take seriously. Another AI research story worth watching comes from Tencent Hunyuan 3D, which introduced a system called WorldClaw for generating large explorable 3D worlds from a single open-ended text prompt. The interesting part is not just that it can make a scene, but that it aims to keep the world coherent at the big picture level while also preserving detailed, editable objects inside it. That combination is important. A lot of generative 3D work can produce something visually impressive, but much less of it gives creators a world they can actually reuse, modify, and build on. WorldClaw tries to push toward game-like environments rather than one-off renders. If this line of research keeps improving, it could shorten the path from concept to prototype for games, simulations, virtual production, and other 3D workflows where control matters as much as speed. And to close on something lighter, there is a wonderful deep dive into the Gorton font, a typeface that many people have seen for years without ever knowing its name. The essay follows how this plain, mechanical lettering style spread through New York City and far beyond, thanks largely to engraving machines that made it a practical default rather than a design statement. That is what makes the story memorable. Gorton was not trying to be beautiful, it was trying to be useful. And because of that, it ended up everywhere, on equipment, on signs, on keyboards, and in the quiet visual background of modern life. It is a reminder that some of the most influential design choices do not come from branding teams or trend cycles. They come from tools, constraints, and the habits of the people who build the physical world around us. Thanks to our sponsor, SurveyMonkey. Don't just know what happened, know why. SurveyMonkey can help you unlock insights by combining feedback with operational data to give vital context. Find the link in the episode notes. That is all for today. If one theme tied this episode together, it is that the hidden layers of technology matter, whether that is private reasoning inside AI models, the math underneath prediction, or the design history buried in everyday objects. Thanks for listening to Trend Teller on the Automated Daily, Hacker News Edition. Links to all stories can be found in the episode notes.